And now we can use this as our cutter planes for the Boolean fracture. The thing is that the Boolean fracture will also calculate all of this intersection over here that's happening outside of our slice of geometry. So we really only need to isolate the cutters around our geometry. So from this node, I will drop down a bound, and let's maybe untemplate this. So this will encapsulate all of our geometry inside a box, and I will increase the lower padding, maybe just a bit, and maybe 0.5 on the upper padding as well. And let's maybe preview this and template this bound node. Okay. So now we can use this bound geometry to create a group for our cutters. And so from this cutter geometry, we can drop down a group node, and I will set this to be points. And I will disable the base group and enable keep in bounding regions. And for bounding type, I will set this to be bounding object, and I will use this bound geometry as our bounding object. Okay, so we can see that we select only the points here that are inside of this bound. So from here, and I will make a little bit of room, I can drop down a blast, and I will set the group to be this group that we just created with our bound, and set this to delete non-selected. So now our cutter geometry is only just barely outside of our original geo that we want to fracture. So we can preview this here. Okay, so we don't need to waste all this computational power on areas that are way outside of the geometry that we are interested in. So from here we can place the geometry inside a fracture node. So let's drop down a Boolean fracture. And we will arrange all of this in a second, so it hopefully makes more sense. And so this is the geometry that we want to fracture over here, this piece. And now we can set our cutter planes to be the second input here. So this will be the cutting surface, and let's preview this. And here we have it. Okay, and I can also drop down an exploded view, and we can see our pieces clearly. All right. And let's delete this. And like we mentioned earlier, we will have to set this name attribute option to append. And again, I will just use a hyphen here for the piece prefix. So if I go to the geometry spreadsheet for the for the primitives, we have piece 1 where it came from. Then this 0 will be corresponding to the first fracture that we did over here. So the first 5 pieces that we generated. And then finally we have the last one, which will be the one that we just created with this grid cutters. So let's maybe rearrange some of these nodes a little bit, just so we make sure that everything makes sense. So from our original geometry, I'm just holding Alt and clicking on this wire, and we can create a dot over here to rewire some of these wires a bit. Okay, so here we have our grid. And let's see, this is the bound over here, and make some arrangements here. Okay, so we are creating a VDB, so we can scatter some points inside this volume. We randomize the normal and the up vectors, and then we copy our grids onto these points. So this is just a simple grid, and then we use a group that uses the bound of our piece to group the points of the grids that are just slightly outside of the surface of the geometry. And then with this blast we optimize the cutter planes, and then we simply use this as a Boolean fracture cutter. And now we can make the cutters more interesting if I add a noise to this grid. Okay, so from this grid I will drop down an attribute VOP, and let's go ahead and rename this to add noise. And inside here, from the P, I will generate an AA flow noise, which is set to a 3D noise. And let's add this to our P and plug this into the P output. Okay, and we can promote frequency, offset, amplitude, and roughness, and go up a level. And maybe I will decrease this, so we will have 2 layers of noise, and we can decrease this a little bit, and maybe decrease this even more, and increase the amplitude, and maybe also decrease the roughness. Okay, so this will be our big noise, and then we will have a small noise to add a little bit more detail. Maybe increase the amplitude even more. So let's take a look at how this will look. So now we are starting to introduce a little bit of details in our subfractures. So this will be our first layer of fracturing with the grids, and I want a little bit more detail right along the cuts that these grids create. So I can go ahead, and before we add our noise to the grid, I will drop down a copy and transform, and I want to create two copies of this grid, which are both going to be pretty much overlaid on top of each other. So if I were to translate this on the y-axis, we can see that we have two planes now. Okay, so I'll bring this back, and from here, if I drop down a connectivity node, this will now recognize both of our grids. So for one grid it will assign a class value of 0, and for the other it will assign a class value of 1. And we could increase this total number, and it would assign a different class value for all of the copies. And now we can use this connectivity attribute to generate a different noise pattern for each of the grids. So inside this add noise VOP, I will go ahead and I will bind import our class attribute, and this should be an integer, so make sure that the typeset is integer. And from here I want to double click on this offset handle, and I will get rid of this actually, and from the class value from our attribute I will type float to vector, and I will create a new vector which I will plug in my offset input. Now the noise for the grids are slightly different. Let's maybe accentuate this difference if I drop down a multiply after my bind import. Or actually I will drop down a multiply constant, and I will just multiply whatever value comes from here with a higher number here, so maybe 1000. Okay, so now we can see that the grids are overlaid on top of each other and they have different noise patterns. So maybe to see this even better, I can go back and maybe offset these a little bit. Okay, let's set this back to 0. So now what will happen is that when the fracturing happens here for our Boolean fracture, this will now, the grids will intersect with each other and they will create these small pieces in between our other chunks. So this will create a little bit more detail, and it will give us variation in the size of the pieces, and it will also look a lot more realistic. Let's go back to the add noise attribute, VOP, and let's duplicate this by holding Alt. And this will be my small noise, so I will rename this to add small noise. And here I can decrease the amplitude maybe to 0.2 for now, and just increase the frequency. And actually let's go back to our grid, and let's increase the rows and columns to maybe, let's add 100 to this, so 350 and 350. And I think we can actually make these even smaller a bit, so maybe we don't really need this to be this big. So let's go with 40 and 40, and for rows and columns let's actually go with 400 and 400, just so we make sure that we have enough resolution to work with. So back to our small noise, let's go ahead and maybe increase the roughness. Okay, and play around with some of these settings here. Increase the frequency. Okay, and let's see how this looks. Okay, so this looks pretty good. And this will be our first layer of fracturing with the grids.